All right, welcome back, Algebra 2 students. Hope you had a nice weekend and enjoyed our weather safely outside. Let's start with a debrief of our warm-up for today, in which we have this classic sock pick or just any really pick problem. A drawer contains 15 white socks and 5 black socks. You randomly choose one sock and without replacing it, pick another sock at random. Our question here, what is the probability that the first sock was black and the second sock was white? Okay, so when we see without replacing, that kind of indicates to us these are dependent events where the probability of event B, where we're going to pick a sock that's white, is affected by the previous event. So my solution for this involves first defining event A and event B. Okay, let's do that. So event A for us is that the first sock is black. And event B is that the second sock is white. All right. Now, what we're working towards and what we saw on Wednesday was the probability of A and B for conditional probabilities. We have that's given by the probability of A times the probability of B given A. Okay, so let's try to work out each of these here. So the probability of A that we just start by picking a black sock. Well, how many total black socks are there? There's 5. Out of a total of 15 plus 5, there's 20 socks total. So probability of A is 1 out of 4 if we reduce that fraction. Now, probability of B given A. The probability that our second sock is white, given that the first one was black. Well, if we want to pick a white sock, how many white socks are left? There should be 15 out of a total. How many are left? Well, there's now 4 black socks plus 15 white socks. So that would be out of a total of 19. All right, so now we go down here. The probability of A is 1 out of 4 times the probability of B given A, we reasoned, is 15 out of 19. Multiply across, we have 15 over 76. And so that's roughly 15 divided by 76 times 100, 19.7%. Okay. So here in this warm-up, we're highlighting some of that stuff from Wednesday's class, namely this formula. Okay. All right, so let's dive into some notes for today. Title these notes section 10.3, and our focus today is all about two-way tables. All right. What is a two-way table? Let's define it. A two-way table is a frequency table that displays data collected from one source that belong to two different categories. So example of like data collection, maybe in our first example, we're going to think about a survey. You go out and you ask people, or in our example, are they attending the dance? And so either they're not attending or they are attending. And the two different categories here, maybe we're asking freshmen and sophomores. Let's look at that example. So suppose you randomly survey freshmen and sophomores about whether they are attending a school concert. All right, so this is hypothetical, but we can imagine this being a real thing. So let's organize. For this example, we're mostly going to just follow along and organize the results that I'm showing you using a two-way table. So this is going to help us become acquainted with the two-way table. So give yourself plenty of space right here, and we're going to start by creating some columns. The first column is going to show us like how many are attending, and the second column not attending. And our third column will be dedicated to looking at total numbers. Okay, and extend this a little bit so that we can write out our rows. Our first row will be for the freshmen. Our second row for the sophomores. And this third and final row will be for totals, kind of like this column. So we're going to see a relationship between these totals and these totals. All right. So I'm just kind of giving you these numbers so we can think about it. Let's suppose in our survey that we surveyed a total of 69 freshmen, and that of those freshmen, 25 said they are attending, and that 44 are not attending. Okay, so 25 plus 44 totals up to 69 total freshmen surveyed. Let's think about the sophomores. I'll go a different direction here. What if we found out that 80 sophomores are attending and that 32 are not attending? Well, think, what's then the total number of sophomores that were surveyed? We just add up these two numbers. So that would be a total of 112 sophomores surveyed. All right. Now let's think about these totals. How many students are attending? Well, 25 plus 80, 105 are attending. How many are not attending? Well, 44 plus 32, we got 76 not attending. Okay. Let's think about this as like kind of a grand total, and I want you to think about these two numbers and these two numbers. Well, you're either attending or you're not attending. So how many students were surveyed in total? Of 105 are attending, 76 are not attending. In total, that adds up to 181. And you're either a freshman or you're a sophomore, so 69 freshmen were asked, 112 sophomores asked. In total then, again, 181. So these totals here, whether attending, not attending, freshman or sophomore, adds up to 181 total students surveyed. All right. And so this is just a very basic intro two-way table. All right. And so where we're going next, we're going to extend this hypothetical concert situation, and let's just write in one bullet point. We can display values in a two-way table as frequency counts, or another way of saying that or frequency, I'm all over the place, or relative frequencies. Okay, I want to add in that bullet point because the next two-way table we make is going to hit more on what we're calling relative frequencies, where we're going to think about percentages and even probabilities. Okay. Remember, you can always pause our videos if we're going a little faster than you prefer. Okay. On page 2 of our notes, 2 of 2, so just our last page here. Let's consider the same example, but now we're going to be asking juniors and seniors. So suppose we surveyed the juniors and seniors. Okay. Sorry, not the end of the sentence. Suppose we surveyed them about whether they're attending the concert. All right, so same case. But I'm going to ask this question, what percentage of the total juniors/seniors surveyed are not attending? Okay, what percentage of the total juniors/seniors surveyed are not attending? So we're going to answer that question using our two-way table. Our two-way table is going to look the same, so here's sort of a solution. Our first column will be for attending. Second column, not attending. Give yourself plenty of space and make this table nice and big. So we're going to write in a little extra things. We have total again for the third column, and then for our first row, instead of freshmen this time, we're talking about juniors, and then seniors, and our third row is for the total. Okay. All right, so I'm giving you this info in some of our homework problems, or our last example after this. We'll be given some values, and maybe we have to work backwards, but I'm just giving this to you. Let's suppose that we surveyed these juniors and seniors. We found out that 42 juniors are attending, okay? And that 64 juniors are not attending. I'm writing this on the left so I can give myself a little space here. All right, so how many juniors were asked in total? Well, we got 42 plus 64, 106. All right. We find out from the survey 77 seniors are attending. 37 seniors are not attending. All right, well, how many seniors were asked? We add these two up. 114 seniors in total were surveyed. All right. All right, so 42 juniors attending, 77 seniors attending. How many total students are attending here? We have 119. Keep in mind, the other example, we're not thinking about freshmen and sophomores, just these, okay? How many students are not attending? Well, we add these two up, and we got 101. And then what's our grand total? How many students were surveyed here? Or how many students are either attending, not attending? So we look 119 plus 101 is 220. That's the same as 106 plus 114, 220. Okay. Now, this is the extension here where we're thinking about these frequencies. So let's think. Now that I know the grand total is 220 students surveyed, what's the percentage of juniors attending? Okay, well, 42 out of 220 asked, that's roughly 0.19. So roughly 19% of juniors surveyed are attending. Okay, this is what we're trying to make sense of using the frequencies. 19% of juniors surveyed are attending. What percent of juniors are not attending? Well, 64 out of 220 is roughly 0.29. So roughly 29% of juniors are not attending. All right. And let's keep going. I'll get to this later. 77 seniors are attending out of 220 surveyed. So that percentage, we got about 0.35 or 35% of seniors attending that were surveyed. And then 37 seniors out of 220 surveyed are not attending, so roughly 0.17 or 17% of seniors that were surveyed are not attending. Okay. Now let's think about these totals where 119 out of 220 are attending. So this is, we got 0.54. So roughly 54% of everyone that was surveyed is attending the concert. Okay. Now, 101 students reported that they were not attending out of 220. Let's go back. What was our question? What percentage of the total junior-senior surveyed are not attending? This is where we are answering our question. 101 students out of 220 are not attending, and that is 0.46. So our question here is 46% of the total surveyed are not attending. All right. And then lastly, the totals here on this right-hand side, just to make sense of them. 106 juniors were surveyed out of a total of 220. So maybe there's a question like, what percentage of everyone surveyed were juniors? Well, 106 out of 220, which is 0.48. What percentage of students surveyed were seniors? 114 out of 220 is about 0.52 or 52%. One thing I want you to notice is if you take these two values and these two values, what should they add up to? Well, what are they adding up to? They're adding up to 1.0. 1.0. Okay, well, this is kind of thinking it's weird, but like 220 out of 220 is 1.0. Okay. So we can use two-ways tables. In our first example, we can use them to show frequencies, kind of like this. In our last example, we can kind of work backwards to fill them out. So here's our final example. Hang in there, folks. One more example. Very simple. No context here, really. Just complete the two-way table. I think these examples are a bit fun because you kind of work backwards and it's sort of like a puzzle. All right. So what if we had a two-way table? There is a context actually built into here. It looks like there was a survey of whether you're in favor or against. I don't know what it's about, but against. And then we have our totals. And they asked boys and girls. I hate actually that I picked an example with the gender binary, so I'm sorry. Our textbooks are not perfect. So let's work backwards. What I'm going to give you, let's suppose that our table is given to us with these values. Okay. All right, that's it. And this is all we get, and we're going to work to complete the table. Okay, so kind of a puzzle. Where can we go first? Well, I'm looking if 184 students or people were surveyed, and there's 88 girls. I'm looking here maybe to start. or maybe you're looking here to start. That 132 are in favor out of a total of 184, so how many are against? Well, just subtract these two. 184 minus 132, here we have 52, okay? Because these should add up to this, and these two should add up to this. So 88 girls, how many boys? We'll subtract these, and then we have 96 boys, okay? I'm going to circle the values that we are figuring out so you remember which we're starting with and ending with. Okay, well now we know that 96 total boys were surveyed, 35 are against. That means how many were in favor? Subtract 35 from 96. So 61 are in favor. And then I don't know. There's a lot of different directions to go here. And now I'm just thinking like 61 boys are in favor plus some amount of girls totals up to 132. So from that, if I subtract 61 from 132, 71 girls are in favor. And our last one, kind of same idea. 35 are against out of a total of 52. Subtract them, and we find out 17 girls are against this thing. So we'll see a few examples like this where you're going to complete the two-way table just by kind of working backwards and understanding the totals and how we add up these things. All right, folks, thank you for working hard. We do have an assignment. Make sure you submit it. It's due by Friday. Let me know what questions you have. Please attend our office hours on Thursday from 12 to 1, just like last week. It was nice to see some of you. Yeah, and let me know what questions you have. Keep it up.